Hey guys, so in this tutorial I will be showing you how to draw a noise map, a layered noise map onto a plane. Okay, so in this project I've just set up a new scene, blank setup and named it noise maps. So to start off with, we're going to go into the hierarchy and create a plane. This is what you're going to be using to visualize it. And I'm also going to go to the directional light, and if it's not white, I'm just going to set it to white. Doesn't really matter, just I like it better like that. So I've created this blank plane, and then let's create this script down here, and this is where everything's going to go. So I'm going to call it noise texturing, if I can spell. Okay, and wait for it to load. My Unity's kind of slow. Okay, and there we go. So just put that texturing script on there, and open it up in your editing software. I have Visual Studio. Alright, so let's delete the starter code. And at the top, just type in execute always in square brackets, and this will allow the script to run in edit mode. And you can do execute in edit mode. There's a couple different ones. Execute in edit mode, but I like always so that I can press play and do stuff. So let's start off by defining some variables. First, we're going to need two public integers, map width and map height. I'm going to set these each to 100. Okay. And then we're going to need a public float. And then I'm going to set this to 1. And then we're going to need two public variables, floats, frequency. And I'm going to set this to 0.5 float. So make sure that F is there. And amplitude. So amplitude is kind of like the multiplier. So I'm going to set this to 1 to start off with. And frequency is kind of, it has something to do with the noise map. It's kind of hard to explain. So then we're going to need a public vector2 and then offset, so you can set this in the editor. And I do believe that is it. Yep, alright. So to start off with, we're going to want a function that will return a 2D float array, and we're going to call this generate noise map. And then we're going to want a lot of little arguments. I'm trying to think of the word. Jeez. Alright, so map width, height, wait, here we go, scale, frequency, just basically everything you defined above. Alright, so let's create a 2D float array and name this noise map, and then just set the length of the float array to map width for the first length and map height for the second length, second dimension, whatever you want to call it. Then at the bottom, just do return noise map, and now you won't get an error. So to start off with, we're going to loop through the x-axis on the map, and then in a nested loop through the y-axis, or second dimension. And this is where all the magic's going to happen. So inside here, we're going to want to create 3 floats. So the first one will be short for frequency, and set that to 1. Then do float amp, just as short for amplitude, set that to 1, and float height, and set that to 0, so it has to update. Then, oh, I knew I was forgetting something. Okay, I'm sorry guys. So we need another public int called octaves, and this is basically like how many scans. So I'm going to set that to 4. Where is it? Scale. Alright. I don't know why I wasn't. Alright. Then we can loop through the octaves, So this is kind of, yeah, like how many scans there are. And let's do a float x coordinate. So this is the affected x coordinate. It's not just the loop. So it's much. This is what's going to allow for parallel noise. So we need. Oh, you know what? I think I want this centered. So outside of the loop. Actually, I can. No, yeah, I need it float. So half width would be map width slash 2 divided by 2, and then half height map height slash 2. Alright, so then I'm going to do x minus half width divided by scale, then multiplied by frequency, the short frequency, because it's going to change per scan, and then the second one, y coordinate equals y minus half height, sorry, and then again divided by scale and multiplied by frequency. Okay, so then we're going to create a value for parallel noise, and then set that to the Perlin value of x coord and y coord. Alright, so then down here we're going to do some math with these three right here. So the value will plus equal or equal itself plus what was it? Okay, I just blinked. I'm gonna have to cut that out. Oh. Okay, sorry guys, so it's not val, it's height plus equals val times amplitude, so the value times the amplitude, and then we're going to multiply the amplitude by the frequency that is inputted, and then multiply the frequency value by the amplitude argument. Okay, so then we're going to set noise map at the coordinates to height. So the final height, after it loops through the octaves, it'll return that height. And then there's one more thing. With all these octaves or scans, whatever, the height will not be between 0 and 1, and we're going to want it between 0 and 1. So to clamp it, actually, okay, outside of this, we're going to create two variables, each floats, my bad. And we're going to set these to, I don't know, the min height will have to be a maximum value so that it will change. So you can do float dot max value, and then the max height can equal float dot min value. So then basically the reason I do for the min height set it to the max value at start is because we're going to want this to be changed so that it is the minimum height value ever inputted, and so that it will be, for later on, we're going to claim it to be 0 and 1 with inverse lerp, and that will take in a minimum value, and I can't set it to like minimum 32,000 or negative 32,000 because it would not return a correct value. So I'll explain it in a second. Just let me see. Alright, so if we just test if height is, I can type, I know I can, I have it in me, is less than min height, then set the minimum height to height, that current loop. And then if height is greater than max height equals height. So same thing, just setting the maximum value. So this will basically set the maximum height value to the highest height value, I guess, that's ever been found. So if you had like 0, 10, 64, 5, whatever, 31, 31, and 41. So if you just looped through these numbers right here, and you set this like minimum value, and then so at the startup it could equal, I don't know, 0, right? And then here, let's do max because all these are positive. So then it would next loop through, I guess, it would max would equal 10 because now it's gone through 2 and the maximum is 10. So by the third time it's 65. By the fourth time it is still 65 because 31 is less than 65, and hopefully you get where I'm going. So that basically clamps it, or clamps the height in between, somewhere in between the minimum height and the maximum height, with one of the noise values being the minimum height. So then outside of this array, once it's done looping, let's create 2 brackets just so it doesn't like change. I hate it when it adds 2 tabs. Okay. And let's see. Alright, there we go. So then we're going to do noise map, or x at the dimensions x and y will equal mathf dot inverse lerp. This will return a value between 0 and 1. And then noise map xy. Alright, so basically what this does is it takes the minimum value, and then it takes the maximum value, and then it takes the inputted value noise map, so that next float, and it finds where in between this, is in between this. So let's say min height is equal to 0, max height is 1, and noise 100, and noise map is 50. Okay, so let's just add commas. Then this would return 0.5 because 50 is halfway, 1 divided by 2, or 0.5 of the way through 0 and 100. Okay, so hopefully that made sense. So we are done with the generate noise map. We got 2 more functions. So we got a void, generate texture, and this is what's going to be used to visualize it. And we're going to need an inputted 2D array called noise map. So then, let's see. Alright, we're going to need a texture 2D, and then just set that to a new texture 2D with, let's see, what's the width? Oh yeah, map width and map height. Let's put semicolon. And then we're going to need a color map. So you can set each individual, the reason I'm doing this is because you can set each individual pixel's color in an array, or you can set all the colors at once with a color map, and it's much faster, less computationally stressful, I guess, if you use a color map and then, or an array of colors, and then set that picture, or the pixels to that. So I'll show you how to do both in this tutorial, but I'm going to start out doing this. So we just need a new color array, and then map width times map height. So this gets every pixel. And then, let's see. So we need to loop through the map width and map height to do the noise maps. Oh, I'm sorry. I need to create 2 floats. So width, and then noise map dot get length, and then the axis or dimension is 0. So this width is the first dimension's length. And then let's just copy that. So y is less than height. No, don't autocorrect. Stop autocorrecting. Okay. Let's just set this now so that it's second dimension and then height. Alright. So inside of this, we're going to set, color map. And because this is a 2D array for the noise map, but color map is a 1D array, well, this is just a little formula. So you take the first value, so x, what am I doing? Alright, x, and then multiply it by the length, the maximum value for the second array, and then simply add y, so this second value. And I don't know how this works, but it does. So let's see. Alright. Then we've got, so new color, and because this color function for Unity is between 0 and 1 for the RGB, it works perfectly because we've got noise map between 0 and 1. So isn't that just dandy? Alright. So float. Why can't... Oh, this is a... Got it. So I can't have floats multiplied by integers. A float is just a number with a decimal, and an integer is a whole number, so 1, 2, 3, 4, 5, and for infinity. And a float could be 0, 0.1, 0.2, 0.3. So, let's see then. Oh, here we go. I knew I was forgetting something. So we need to do texture.setPixel. See, you can do setPixel for integer x and y and set each individual pixel's color. Or you can do the setPixels method and it will take just the color map array, an array of colors. So then in order to get it drawn, you need to do texture.apply. Then, that's to get the texture to be finished. So to get it to draw, we need to access the render component, set the shared material.main texture to texture, and then so that you can see it, it's not microscopic or something. What in the world? We need to check the transform and local scale. Stupid autocorrect. And then set that to new vector 3, I'm sorry. Width 1, height. So this just sets it to the plain width and height, so that it's not microscopic. It's not like 1 pixel big, long, whatever. Alright, and one more function. Then we're done, almost. We need to call it, but so then we can call this draw texture. And then we're going to need a 2-day array. Set this to generate noise map. Then input all the stinking variables that we had earlier. Hopefully you can't hear the music in the background. My sister's watching a movie. I didn't realize she was going to get to the end credits. Okay. And yep, alright, so then we can just do generate texture noise map. So then up here, just need an update function. Then call draw texture. And we need it in a start function because it does this weird bug where it'll like be blank for the first frame. So until you update one of the variables. Alright, so that should be everything, I believe. So just wait for it to load down here. Whoa, it's huge. Why can't... Okay, there we go. Wasn't wanting to scroll. Okay, what is... Oh, you know what? I didn't add the offsets. I'm sorry. There's this... For the offset to work, we're going to need to loop. We're going to need to create a 2D array. And then... Oh. So this will be offsets for each noise value, I guess, for octave, for each scan. So, just loop through these. You know what, I can just do octaves. And then offsets equals new vector 2. Oh, duh, okay. Offset.x, offset.y. So this will set each octave offset to the offset position. Then just add it. No, wait. Sorry. Okay. So something is obviously going wrong, and I'm not sure what. So let's just see if that, by any chance, fixed it. Oh, the scale is so small. That's probably why. Yup, there was the offset. Alright. So if we just zoom in, it looks much... Okay, or not. So you can see it works, but... Here we go. If you multiply the amplitude, it will look much better. 4 seems to work. So there you go. That is how you make noise textures in Unity. Alright, thanks for watching, guys. Hope you learned something, and I will see you guys later.